All right, you guys well? Happy to be here. Yeah. All right, well, thank you very much for coming to the first one. I'm going to take a couple of moments to go through what I hope to cover over the whole course of workshops, and then we can delve into some more of the interesting things. So we're going to start talking about the various database servers that we have available, and then the tools that you can use, move on to how to install them, and then look at doing some initial config, moving on to running some simple queries, then also running some slightly more intensive queries, so if you want to get a report on some data, no problem at all. And then we'll move into the much more interesting things, advanced queries, functions, triggers, all of that lovely good stuff. And then finally we'll take a brief detour into the world of database administration. So I will attempt to, as I said, record these and put them up, so if you miss one, then you've got it. So, before we get started, I'm just going to quote a lecturer that you might have had, Humberto Vasconcelos, who often says in his lectures that you shouldn't take what I say at face value. Yeah, feel free, because you guys obviously, you're paying to be here, so you deserve to get proper education, which is kind of confusing as to why I'm doing this, but that's besides the point. So feel free to challenge, to question. If there's something I say that doesn't make sense, call me on it, because there's no point in sitting there going, oh, that doesn't sound right, and not doing anything. So seriously, I'm a peer of you. I'm not someone who's trying to talk down to you. So please, if there's something you don't understand, stop me immediately, make me explain it. Chances are it will help my understanding as well. So also take the time, if you can, to experiment on your own, and if you want to put some of this stuff into practice, then please do. Hey. So, before we get started, any questions?
So why PostgreSQL?
Why is it highlighted?
Yeah.
PostgreSQL, let me see if I can turn it louder. PostgreSQL is my database of choice. It's the one that I have most experience in, and it's the one that I would recommend if you don't want to pay for a database, but still want to use something that's relatively advanced and can cope with a high workload.
So is it better than MySQL then?
I would say so, yes. I'll get onto that.
Is there because on our course we have MySQL, is there a lot of differences in terms of coursework and stuff like that?
Yes, there is. So something I'll go into a little bit more is dialects of SQL, because you have the ANSI standard, which every database should conform to, but you then have a database-specific syntax, which is down to the individual database itself. So in MySQL, for instance, a very key difference is that you can have capital letters in names of tables, whereas in PostgreSQL, any table name, field name's always lowercase unless you double quote it. So differences like that, they're not all born equal. So as you mentioned, you've been exposed to MySQL in CS2015. You've also had some dealings with Access, I understand? Yeah. Cool. So here are a couple more. You'll also have heard mentioned that there are things as a DBMS or RDBMS, database management system. The components that they were talking about, you've got the actual database server and the management system, they are very rarely separated. So I'm just going to call them database servers, because it makes it easier. So there's a huge variety of open source, tons more than I've listed there, 20 if not more. And you've got a few of the more famous paid for ones that you probably recognize, good old Oracle and SQL Server, etc. MySQL and SQLite are very good if you want to experiment locally with databases. They are absolutely not suited to any system in production. So you will see a lot of people using MySQL with PHP on a PHP website that's open facing to the internet. I would not recommend this. MySQL is occasionally a bit fragile. It will do some quirky things. So it's great for learning, but I wouldn't use it as part of a system, personally. Then you've got things like SQLite. Have any of you used SQLite? SQLite is a brilliant tool if you're doing development, because it is a database that's contained in a single file. So you can, if you have a repository of source code, you can include the database with your code, and so anyone who's developing on it also has your development data. there in the database. It's ready to go. Again, even worse than MySQL, not for production. Testing and development only. Because SQLite is only in fact designed for one user at any time. So, Oracle. Oracle is incredibly powerful, and there are a lot of companies that pay huge amounts of money for it. So if you've got the money, go for it. SQL Server is, I know lots of people are not going to like me for saying this, SQL Server is bad. And I'm quite happy to explain why at the end, if you want me to, but rather you than me in that situation. So then we've got things like Microsoft Access. Microsoft Access, I'm sure you've discovered now, is hellspawn. And again, it's a little bit like SQLite. People only use it locally, and you can share databases around with people. You'll find that the GUI will obscure lots of details about the stuff behind the scenes, so you can create stuff without writing SQL. And in some cases, their aim is that you don't have to necessarily know much about databases to use it. And in some cases, that can be a danger, because you'll do something, it'll do something strange. You won't quite understand the effects of what's been done by Access. So, lastly, as you pointed out, PostgreSQL is highlighted. It's my favorite. I think it's the best. Again, personal opinion. And it's the one that's running in the sandbox as well. So it's the one that you guys will be experimenting with as part of these workshops. PostgreSQL is a bit of a mouthful, so lazy people like me will just say Postgres or PGSQL. Very, very quickly, since I'm not a member of staff, I can get away with including vulgar jokes and things. So I'll show you guys what I consider to be a favorite website of mine, called howfuckedismydatabase.com. It's brilliant. It would help if I was connected to the Wi-Fi, however.
Does it perform tests on your database?
No, it's basically it's effectively a joke, and you click through it gives you a list of databases and like, what are you using? And you click Microsoft Access and it says massively fucked. you click Oracle and it says how much money do you have, and gives you millions or less than $1 million. If you click millions, it says, or if you click less than $1 million, it says good luck with that, and says insert coin to continue. It's great. Unfortunately, Eduardo is not willing to work with me today, so let's just continue on. Look that up if you want. It's a great laugh. It's got a fantastic comic about, have you looked at NoSQL databases like MongoDB? It's got a great comic about those. Absolutely brilliant. Now that I've introduced the database itself, what's the next slide? Okay. pgadmin and PSQL are a couple of clients that are used to connect to PostgreSQL databases. PSQL is a command line only tool. It ships with PostgreSQL, and you can use it if you like. You have to remember the semicolons at the end of your statements, but it's very basic, and I wouldn't use it on a daily basis. pgadmin is basically the only thing available that's specialist or that's specifically designed to work with Postgres. It's not great, I'll be honest. Right, so this is pgadmin, and this is the main window you'll see when you open the program. On the left-hand side, I've got a list of saved servers, so there's the sandbox. And then you can connect to the various servers. So let's just set up the demo I have, or try to rather. I'm going to do, come on, there we go. Oh, this is going to take an age and a half. I reckon it might take 5 minutes to drag my mouse from one corner of the screen to the other. This could be bad. Okay, so good, that's running perfect. I hope you're on the right IP. This is going to be an installation of PostgreSQL onto Ubuntu, I hope. Postgres.
And what was the second word you said?
Ubuntu.
Ah,
Ubuntu is a
yeah.
distribution of Linux. Yes. Okay, so you've got PostgreSQL is cross-platform, so you can install it on Windows, install it on Unix, Linux, as we're going to be doing, Mac OS 10, you name it. The installation procedure varies a little bit, so on more graphically oriented systems like Mac OS and Windows, you get a wizard installer. For things like Unix and Linux, you have the command line. So what I'm going to do is I'm going to run this command, which will install the Postgres 9.3 database. So it's going to ask me for my password. That is the right password. There we go. So this is how easy it can be to install a database. This is probably going to take 30 seconds to a minute, if that. Okay, so it's just about to start it. There we go, all done. Nice and quick. So PostgreSQL is now running on this machine. There are a few things we need to do before we first connect to it, and there are a few default settings we have to change. So I'll take you through those now. First of which is we need to control the connections that are allowed to the database. These are done on the basis of IP, username, stuff like that. And often you'll find in proper installations there will be several different special configurations to control the security of the database. The file is called pg_hba, and on Linux it lives in this directory. So if I open that file up, you can see there it is, pghba.conf, right there. Oh, great. Blue text, right. In this file it tells you, most configuration files on Linux will tell you how to configure whatever service it is that you're trying to set up. So all of these comments in the top of the file tell you about how the file is laid out, the various options you have to configure the connections to the database. The reason we're doing this is, by default, Postgres is not configured to accept connections, which seems a bit strange, but they do that so that it starts in a very, very secure state, and you can lessen the security as you need to have more flexibility, for instance. So if we take a look at the lines that are in this file, they all have this format. So you first specify the type of connection. You then have all of the databases that this particular connection is allowed. Again, same for users. If you're doing a host type connection, you then have an IP address or a range of IP addresses. And then finally you have you have a method of authentication. And I'll talk in a bit more detail about these shortly. First of all, let's just make sure that we can connect to the database. So this will be the first instance you see of PSQL, the command line client. Every database has built into it a super user. And that super user is essentially there in case of accidents. It's used when you first set up the database, and it's used if you have something goes horribly wrong and you have to recover things. Generally speaking, you should not use it on a day-to-day basis. The super user for Postgres is just Postgres, and on every operating system that you install it on, it will create a Postgres user in the operating system itself, as well as in the database. So the command I'm about to run is going to switch into the Postgres user. And there is a reason for doing this, which I'll explain in a moment. So switching to the Postgres user and running PSQL, it will give you a prompt. This is one of the first steps that you should do whenever you set up a Postgres database, which is to provide a meaningful password to the Postgres user. Because it's the super user, you should protect it and hold it dear to you, because if that goes wrong, you are almost completely buggered. You won't be able to do much with your database, because if someone malicious gets a hold of that account, they can shut you out, they can drop everything in the database, bad things. So this will be in some notes that I publish, but the command is alter role, and then the name of the role with password, and I'm just going to give a very, very simple password, going completely against what I told you, and then the semicolon at the end. If you don't include the semicolon, this will happen. It will follow through to the next prompt, because it's expecting you to finish the command and then terminate it with a semicolon. So if I type the semicolon now, it runs, and it succeeded. So I can now quit out of PSQL, which is \q, and then we drop back into our standard shell, and now we're back to my user having switched to Postgres, which probably seems a little bit weird and roundabout at the moment, but it will all make sense, I promise you. So the next stage, once we've done that, is we need to make sure that Postgres can accept connections in the first place. So we do this by editing the main PostgreSQL file. There's the root user. And you'll see a lot of blurb. This file is quite long, contains lots of internal variables that you can configure and tune, and a lot of people will spend a lot of time and a lot of money trying to get these settings right. Some of them are quite trivial, others are not so. The parameter we're looking for is called listen. And listen, commented out there at the bottom, specifies where Postgres should be looking for connections. By default, it is local only, so it only looks for connections from itself to itself. We want to change that. We want to connect to it from the network. So what I'm going to do is I'm going to uncomment this line, and then we're going to change localhost, and we're going to be very, very insecure, and we're going to put star to mean everything. The reason that is insecure is if you have several different connections into your machine, Postgres will be listening on all of them. Some of those connections may not be so secure as others. You may not want people to connect from a particular network. You may want to pen it in to only a certain few people. So normally this is another one of those things of do as I say, not what I did. I'm doing this for the purposes of simplicity. So save the file. Whenever you make changes to these files, you must restart the database server. Various different ways, of course that varies on the platform, but this is just going to be a quick and easy restart. There we go. Cool, so that's that done. So we can now try to connect to this. And I'm hoping that this is not going to work. Why, I hear you ask? Right, let's try. Come on. Yes! Excellent, this is what I was hoping for. The reason we're getting this message is because, you remember that PGHBA file I told you about? We don't have an entry in there that tells us that this computer is allowed to connect to that database. So pgadmin here, remarkably, is being quite helpful. So it's telling you a line that you can put into that file to set it up to allow connections. And I'm going to do roughly that. So, moving on, if I could type. Oops. Cool. So, this is the point where I explain various things. We're going to add a new line just below this one. This line here says this is going to be a network connection for all databases, all users coming from localhost only and validated by a password. So we're going to do something similar. We're going to go. I'm going to change this to be Postgres, so that it only applies to the Postgres user itself. And I'm going to change this, come on, to be the local network. Authentication is going to be done by password MD5. Save again, restart. Come on. Now what should happen is when I connect to this database, it should let me in. Anyone want to place some bets? Well, hey, there we go. So we're connected to a database server. If
So the
people-
data, I apologize.
Go on.
So the database is kept on a server.
Yes, you've raised an important point that I'm about to delve into actually. A database server can host various databases. Having one per server is a little bit wasteful. So you see we've already got one database, but we never made a database. This was made by Postgres itself. When you connect an application to a database server, you almost always connect to a specific database in particular. So if you're using the JDBC in Java, if you're using PHP, any kind of database connector, you say, I want to connect to this database server on this port with these details, and I want to connect to this database. That's a standard pgadmin error which most people ignore. And I'm going to do what most people do. So, what we just did was we enabled some basic access to our server. Right now, there's nothing on it. I say that there's nothing on it. There's basically nothing on it. This Postgres database is very important. If I can find my notes. I'm sure that you got told as part of the course, every database will store information about itself. And a database should be able to answer queries about its own structure, not only internally, but also of other databases. So that's the reason that it knows that a particular table has a particular name. If it's not stored in the database itself, it's stored in that internal database. So if for some reason you find that you've got a Postgres server, that database is missing, you run, because it's going to explode, probably. So, if we look at the PGHBA file, oops. Come on, you know you want to. Wow, there we go. Right. This, has anyone ever dealt with a firewall before? You don't have to say yes. Cool. So, this file works similarly to a firewall insofar as each rule has an implicit priority. When the database reads this file, it goes top to bottom. The first match it finds is the one that gets picked. So for instance, we could have a bunch of rules, because these are what these are, in this file that apply to this particular network. And we could say, okay, so this user is only allowed to connect to this database. This other user can only connect to this other database. We may say that this user doesn't have to use a password, whereas everyone else does. And that's what you can control using each one of those rules will be an entry in this file. Because it's read top to bottom, you will see that you have what are called catch-all rules, like this one here. Sort of. There are some examples down here, but if you want a catch-all, for instance, so anyone can connect to any database from any network for as long as they provide a password, you should put that near the bottom of the file. So let's explain the default ones that you get. These are, this top one, actually these top two are very important. This top rule is what allowed us to open the PSQL utility as the Postgres user. It's another one of those things that if it disappears from your file, you're in trouble. Because this essentially allows sort of a backdoor into your database, but it's severely restricted by this lovely little word here, peer. What this word means is that you have to connect to the database from the database server itself as the Postgres user on that machine. You can't do it any other way. So you have to be logged in under the Postgres user, you have to use the PSQL client, and you have to be logged into that particular machine. This line just below it does a similar thing, except for it's all users. So if you have a user in the database, call him Fred, and you have Fred is also set up to log into your database server, then Fred can connect to the user on the database without having to enter any password. It flows right through. So more for convenience than anything else. You have options like MD5. MD5 requires the user to enter a password, and it's sent in an MD5 hash over the network. Unfortunately, your only other option is send the password in clear text. Don't do that. Never do that. I don't wish to be deliberately threatening. If I somehow find out that someone has done that, bad things will happen. Just saying. So that's essentially what this file does. It allows you to restrict, open up, however you want to do it, connections to your database. And if I have the time, I will show you the one that I'm going to set up for the sandbox, where every user will have their own entry. A couple of interesting things to note. So far you can only see peer and MD5 under method. Excuse me. There are actually quite a few more. If you go and check out the PostgreSQL documentation, you'll see what I mean. Because there are other important things, like there's a particularly important one called trust, which means that trust is much less restrictive than peer. And what it means is that do not check this connection for authentication at all. So if you, for instance, if I wanted to trust a particular machine, say I had another server on my network that was hosting an application that connected to this database, I didn't want to put a password in the configuration. You can set that to trust, and what it will do is it won't question the server that's trying to connect to it. It will just say, you've got this IP, you're trying to connect to this database as this user, fine, go ahead, not going to stop you. So use sparingly, but it's a useful way of avoiding certain things like, again, putting passwords into configuration files. So, right, there is basically one last thing we need to do to get ourselves up and running, which is some basic tuning. To allow it to operate properly across different platforms, PostgreSQL is set up with very, very restricted settings in terms of its memory usage. For instance, the reason for this is that some older platforms, like Unix, require you to do crazy things like recompile the kernel to allow programs to use certain amounts of memory, which is, you don't want to do that. So for that reason, it ships very conservatively. So among your list of things to do when you install Postgres is to change these settings so that it will actually give you some performance. And we have the time for me to go into why. While I was at work, we had a machine running PostgreSQL with a database that was quite frequently accessed, running some fairly heavy queries. And we noticed, because we were running it in a virtual machine, we could see how much processing power it was using. Now, your standard laptop might be dual core, something like 2.5 gigahertz. That's 5 gigahertz in total if you're using all of it. This machine was using 10 constantly. So it was chewing and chewing through power that we couldn't afford to give it. The reason for this is that no one had bothered to tune the memory settings for Postgres. So whereas it could be caching results from queries, it couldn't because it wasn't set up to use the available memory. The moment that we tuned those settings, we didn't see any processor usage spikes past 5 gigahertz. It more than halved. So I hope that impresses the importance of getting these settings right. And which is why I said earlier that people will spend a lot of time and a lot of money trying to get them right, because it can save you a lot of money in the long term. So, very quickly, I'm going to run through changing those, and you can see how to do it. Unfortunately, on Linux, we have to change a particular variable. Oops. Cool. There are two variables, in fact, we need to change. One is called shm_max, and the other is called shm_all. What these variables do is they tell the Linux kernel how much memory a process is allowed to have to itself. By default, I think it's something like 320 megabytes. Not enough for a database, essentially. So there's 4 gigabytes of memory on this machine, and I'm going to set SHM max to be 2 gigabytes. The unfortunate thing about this is that this field is literally in bytes. No scale at all. You have to work out exactly how much it is. So if we do 2 times, and then you've got 1024 gigabytes, can anyone remember?
Yeah.
Power 9. No, it's not. Sorry. It's 10 to the 9. 3 times. So that's the number that we're going to have to pump into this config file. Because I'm lazy, I'm going to copy it to the clipboard, if it will let me. No. Or yes. How did that end up as 1? Okay then. 21474836. This is the one downside to this. 214748. Anyone watch Rain Man recently? 3648. Okay, cool. So that's the first number. God, that projector's terrible. I'm very sorry. Oh well. That number is in bytes. The number below it, however, is not in bytes. It is in fact in what are called memory pages, because it is a unit of allocation. So what I'm going to do, hopefully this will work, get config page size, I think. There we go, right. In most systems, the page size will be 4 kilobytes, 4096 bytes. So essentially what we have to do is we have to divide that horrific number by the unit of allocation, which in our case is 4096, gives us 524,288. Must be a multiple of the page size and, of course, so on and so forth. What you'll want to do is, because this is quite an irritating procedure, as I'm sure you've gathered by now, you'll want to set those limits in that file to be higher than what you're going to give PostgreSQL, so you've got some room for expansion. Those are, if anyone's interested, those are kernel level variables, and in Linux they are stored in that file. Again, if you want to know plenty, all of this is easily Googleable if you get stuck. It's just important that you need to know roughly what needs to be done. So that's that done. Unfortunately, because it's kernel level, it requires a restart. So we're going to give that... how long do we reckon it's going to take? Let's have a look. Restarting. Hey! Okay, there we go. Wonderful. So that's that restarted. We're going to now change the settings in the Postgres file. Main config file, postgresql.conf. This file is a little more forgiving. You don't have to put in your field in bytes, thank goodness. So as this here shows, you've got memory units right there ready for you to use. So I set those SHM max, or set the SHM max file variable to 2 gigabytes. I'm going to give Postgres 1. Just to prove my point, I need to find, as I'm sure you can see, right, this is the important bit. So this is what I mean by Postgres ships with very conservative values. It is 128 megabytes, which is nowhere near enough. So what we're going to do is we're just going to sneak in and change that to be something sensible. Job done. You've got a few more options here which are probably worth changing while you're at it. Temp buffers essentially specifies the working memory per query. So if you're running a very, very big query, or if you're often running big queries, you're going to want to bump this value up a bit, because otherwise your performance is just going to be through the floor. So uncomment, and we're going to change that to something meaningful. Let's say 128 megabytes. That should be enough. When you think about it in terms of the actual raw space that a variable takes up, for instance, an integer is, I think it's 1 or 2 bytes. So actually, when you think about it, that's a lot of space. So plenty to be playing with. Sometimes you can get result sets which are absolutely huge. So you might have to increase this further, but this is a good start. You then have things like working memory, which does the same thing or similar. And again, we're going to change that to be something sensible. 128, the same. And then finally, you've got maintenance working memory. Now, perfect time to wrap up. This is also very important. Postgres has a few processes which look after the database itself, which help give statistics about the database. The reason that's important is because when you enter a query, the database will try and work out what is the best way to execute that query. And if the details of the database aren't up to date, then that's not going to give you an optimum result. This parameter here, maintenance working memory, controls the amount of memory available to those little processes that keep things clean and tidy. So again, we're going to change it to something meaningful. In this case, it's going to be 512 megabytes. Just because. Again, because we changed the config file, that's a restart. Come on, I typed. At least I thought I did. There we go. Restarting the server. It should come back alive. There we go. And we can see now that we should be able to connect to it. Wow, PG admin, you're looking very compressed today. Right, I should let you guys go. But next week, what we're going to cover is creating the first databases, users, roles, permissions, that kind of stuff. And also transactions, as I mentioned. But thank you very much for coming. I will get back to you about where we're going to be.